Assalamualaikum and salam sejahtera. For this lesson, we still discuss about intermolecular forces, and for this lesson, we have to discuss the type of intermolecular forces, which is ion dipole forces and dipole forces. First of all, we have to know what is dipole. When we want to discuss about the ion dipole forces and dipole forces, we have to know what is dipole. In a chemical bonding, polar molecules have a partial positive charge on one side and a partial negative charge on the other side of the molecules. You can see here like this. In the polar molecules, one have a partial positive charge and on one side and partial negative charge on the other side of the molecules. And the separation of the charge, we call it dipole. For ion dipole forces, as you can see here, and ion dipole forces is a result of electrical interaction between an ion, this is the anion and this is the cation. This is the electrical interaction between an ion and the partial charge, and the partial charge on a polar molecules. This is what we call ion dipole forces. You can see here in the figure 4a, the positive end of the dipole is near an ion. It will attract negative positive, right? So for B, it is the negative end of the dipole is near the cation. You can see the difference, right? So as we expect, the orientation of a polar molecule will be like this. The positive end of the dipole will attract to an ion, of course, right? And the negative of the dipole will attract to the cation. And ion dipole forces are particularly important in aqueous solution of ionic substance such as sodium chloride. For the sodium chloride, polar water molecules will surrounded by ions. And ion dipole forces are stronger than dipole interaction because the charge, the charge of any ions is much greater than charge of a dipole, where the strength of the ion dipole force is proportionate to ion charge. That's why ion dipole forces are stronger than the dipole interaction. So now we go to the dipole forces. Dipole forces, is the electrical interaction among dipoles on neighboring molecules. Before this is ion dipole forces. It is among ion and dipole, right? This one, dipole. We call it dipole because it is the interaction among dipoles on neighboring molecules. From this dipole to another dipole in the molecules, with the neighboring molecules. The force can be either attractive or repulsive, depending on the orientation of the molecules. For your information, the dipole forces are generally weak with energies of 3 to 4 kJ per mole. And it is significant only when the molecules are in close contact. And the strength of dipole-dipole interactions, dipole-dipole interactions, depends on the size of dipole moment that involved in the interaction. Okay? The more polar the substance, the strength of its dipole interaction, the strength of its dipole-dipole interaction will be greater. Okay? For example, as you can see here, butane C4H10 is a non-polar molecule. Okay, you can see the molar mass is 58 mol or gram per mole. Okay, and the boiling point is equal to minus 0.5 degrees Celsius. Okay, you can see here, this is acetone. Okay, it has the same molecular weight, with the butane. It is equal to 58 mol or 58 gram per mole. Okay, but you can see here, the boiling point for acetone is 56.2 degrees Celsius. It is very different, right? Okay, this is happen because acetone is more polar and have higher dipole moment than the butane. Okay, so we can say that the substance with higher dipole moment generally have higher boiling points. Okay, so now you know about ion dipole forces and dipole forces in the intermolecular forces. Okay, that's all for this topic. For this lesson. Thank you and stay tuned.